Hello and welcome to this video on oxides. Oxides are a class of chemicals that have an oxygen molecule and one element that make them up. The most common form of oxide people would think of is rust. This is a combination of iron and oxygen. That shows up as a brownish to red, sometimes black powder-like film on iron-based metal objects. This could be everything from steel and derelict cars and buildings to naturally occurring iron-rich rocks. Oxides are important not just because of what they are, but where they're found and what they do. Oxides occur because oxygen has a net negative charge of 2. This means oxygen can create an electron or covalent bond with other molecules. Any molecule set up this way with the negatively charged oxygen ion is an oxide. While metal oxides generally will be a solid at room temperature, you also get them in gas form and liquid form. Water is perhaps the most obvious form of liquid oxide. You have gas oxides like nitrous oxide, for instance, sulfur dioxide and carbon monoxide. Even CO2 or carbon dioxide is technically an oxide. They are ubiquitous and found just about everywhere and in all kinds of ways. Naming of them is relatively straightforward for the most part. You have an anion in the form of oxygen, and you have that bound to something else. So for example, if it's something like copper, it could be copper oxide. If it's iron, it could be ferrous oxide. We've already mentioned examples like nitrous dioxide and carbon monoxide and dioxide. Where this sort of naming convention doesn't necessarily work, they'll use the ratio between the cation, or the molecule that's not oxygen, and the anion, which is the oxygen. This is sometimes a much simpler approach, and a very simple but effective example is dihydrogen monoxide, better known as water. When you get these oxides beginning to form in enough concentrations that they begin to interact, they form predictable patterns. It's generally described as being something very similar to a polymer, that being plastics. You begin by having 3 to 6 of these molecules linked together. Each of them then forms a solid that is relatively insoluble in water. In some instances, you can have only one particular type of oxide forming it. This is commonly seen in things like rust. All oxides have particular features to them, and that regards their pH. They're either going to be a neutral, amphoteric, basic, or acidic, and this will depend on their characteristics. Your acidic oxides will have a effect of giving off hydrogens when they're put in water, primarily by drawing off the oxygens that are there and releasing the hydrogens. Your basic oxides will take those hydrogens out of water and create a negative charge in the water to prevent hydrogens from being freed up. When it reacts both ways, this is your amphoteric oxide. Neutral oxides are ones that will not have a reaction either way. This reactivity is also why when oxides are used in conjunction with water, they can be much more effective for their intended purpose. Because oxygen and hydrogen in water have their necessary charges on each, they can, to a certain extent, amplify the effect of an oxide by working with it in the direction that the reaction's occurring. One reason this is delayed in many cases, and why you will see things like rust forming on metals that are left outside, is that they will often develop an oxide coating on their surface. This oxide coating prevents the material further in from reacting with the atmospheric oxygen. This thereby prevents oxidation. Without oxidation, you don't get the formation of an oxide. This is also called a passivation layer. This is meant to protect the relatively pure material from reacting further and therefore corroding. That is until natural weathering, such as rain, wind, or other erosion, removes that oxide layer and fresh material is exposed to react again. To see this for yourself, take a piece of aluminium foil and put it outside. over time you will see the formation of a thin white veneer over it. This thin white layer is the oxidation of aluminium. It is a dialuminium trioxide layer. This, unlike other formations you may see, is not the deposition of things like mineral salts, which would occur if it was, say, on the side of a pot where soil will salt out. Rather, this is simply rain and oxygen from the air. If you keep the foil in a protected location, you should still see the same reaction occurring. That's because the oxide forms regardless. Thank you for watching this video. If you have found it interesting, consider liking, sharing, and subscribing. Please post any comments, questions, or suggestions you have below.